I don't think there's anyone else coming. Sitting down.
Welcome.
Welcome to the first Leeds Chat of 2020, new decade. Hope everyone had a good time off. Seems ages ago now, doesn't it?
Just seemed ages ago.
Yeah. So we're slightly more organised this year. I think we're well ahead with the talks. I think we're up to April.
Well, we've got 2 this month as well.
Oh yeah, we've got 2. Yeah, we'll see how that goes. Because I think last year someone couldn't make it on the Thursday and we had it on the Friday and it was a complete disaster because everyone's used to Thursdays. Right. But anyway, there's another one. This one,
Yes.
right? Okay. And it's Paul, is it? Is that your talk?
It is.
I think it'll be in February.
February the 13th, it's not this one.
Oh, right.
Oh, sorry.
So we've got 2
I'm
talks.
rubbish at advertising. Ignore me.
Right, cool. I've got a bit of industry news.
Okay, it's good. I have 2 if you've not already got it then.
All right. So for any Mac users out there, including Martin, Apple's now got 1.5 billion and reached. There now as many active Apple devices as there are PCs. So if you're ever wondering, if you made the right choice to switch to an Apple device, you have. This one's not .NET related, but I thought it was funny. Tesla is offering free supercharging until the coronavirus epidemic ceases in China. So if you're in China and you've got Tesla, you get free charges.
That's so relevant to this group now.
But it came up in my .NET news. I don't know why, but I thought it was funny. That's such a PR scam, isn't it? It's like, if you're running away from the virus, you can get
The last equality is not fully charged.
Right. So get a bit of Amazon news since it's not great news. That's the only thing I've found is that about the Ring. Anyone got the Ring? The thing you got that?
What's the Amazon Ring?
So there's a bit of a thing around third-party trackers selling and collecting customer data. Yeah. So that was in the news. It's a day old, so it's definitely news. Apparently, if you've got an Android device, there's about 3 trackers on there, or something like that, which personally identifiable information as well. So, run home. What else have we got? There's lots of excitement around Blazor. Anyone play with Blazor? Yeah, so there's third-party tooling coming out, and
you can use it for mobile as well now.
Pardon?
You can use it for your mobile UIs now as well.
Can you?
I'm desktop.
It looks really cool. The Blazor WebAssembly 3.2 preview is released an hour ago. That's definitely hot off the press. Another one from Mac devs, .NET devs, Visual Studio 2019 for Mac version 8.5 preview. 2 is available now. That was 12 hours ago. And then Windows, this is for us Windows users who are stuck with the Windows boxes. Windows 10X reportedly featured dynamic wallpaper. Wow, that's a reason to switch back from Mac to Windows, isn't it? And then there's loads of Microsoft got their earnings reports out, and lots of it was down, but the one thing that was up was the Azure revenue apparently grew by 62%. So yeah, it's just it's good. Yeah. So if you've got stuff on Azure, you can rest assured that
You make helping Microsoft make money.
that's right. You're helping Microsoft make money. What have you got?
Okay, so mine was I was a reluctant convert to Git and used Mercurial for many years and really loved it, but I am now mainly a Git user. And Bitbucket recently told me they were going to delete all my Mercurial repos, and I've been porting them all over into Git. But GitHub were recently bought, or recently-ish, this isn't like 2 hours ago, this is probably like 2 months, ages ago.
Maybe over a year ago.
This is year-long news, but when they bought them out, GitHub now supports private repos, so I can move my Mercurial repos fairly painlessly over into GitHub and still keep them private if I so wish. and then the GitHub sort of import tool has been made all my old Mercurial GitHub, Mercurial repos have a new lease of life.
Anyone use Mercurial?
No.
It's just us two.
It's just us two. It's your fault. It's my fault that you
It's
use
your
it.
fault.
I used to.
That's redundant. Used to use.
Most
Not
of my stuff
anymore.
in that are old uni projects.
But yeah, so the news part, anyway, if you missed it, was that GitHub now supports private repos for a free account, so you don't have to pay them for your private repos.
Makes you wonder why they didn't do that.
Well, it's because they
It's
were
the only
very-
reason people went for Bitbucket, right? It's because of that.
Pretty much.
Well, yeah, they were opposed to each other. One offered free public repos, one was free private
But
repos.
GitHub had a very sort of pro-open source thing. It was like everyone should be open source, everything should be open source.
It's definitely more hit if you went.
Yeah, but which is why I wasn't. So I think that's my news.
Cool. Anyone remember? Do you remember what next talk is in Feb? Yours?
Is that Oh yeah, it'll be. So that what David is your?
Go tell us about your talking to.
Logic apps and serverless functions,
Cool.
and
It's 13th of
13th of Feb. So that's the put that in your diary. It's not that long.
That's not. I'm hearing a lot of clients talk about serverless. It's another hot topic.
My boss gets very excited about it.
Well, it's
and then we
massive
never
cost
get around to
saving.
using it.
Yeah. So yeah, glad to have a talk about that. So that's next month. Now, coming on to our main talk, Martin has kindly agreed to return from last year, which was one of my favourite talks of last year, I'd say.
Oh, that's so kind of you to say when I'm right here.
No, it was.
You say that to all the speakers.
Everybody, all on camera.
So Martin's been travelling around a little bit. You were 7 years at Microsoft, right?
Yeah.
And then you had a short stint at Oracle, yeah?
Yeah.
And now you're at AWS. Why do people say I'm from AWS? Can you not say Amazon? Is that not the same thing, or is it different
They're
division?
the
or
same,
something?
same company, but they do different things.
Right.
You
Yeah.
know? Yeah. I mean,
Obviously. Yeah.
Yeah.
but if
Yeah,
you're
mine's good.
AWS, you don't say I'm from Amazon. You
Well, no,
say-
yeah, I'm at Amazon, so I work for Amazon. It's
then
not.
we
They're not
might-
separate companies.
We might complain about why our deliveries didn't get delivered on time.
Ah,
Or
right.
Precisely.
Why it got left in the bin.
Or you ring doorbell or something like that, like another division. Like, I don't know.
I won't ask you about that. Anyway, so there's Martin. He's just come from NDC London this morning, so thank you for that. And you'll be talking about .NET Core on AWS.
Yeah, cool.
Welcome. Give him a hand.
Sorry, just
We good? Let me just connect this up a little. That's peculiar. There we go. Okay, so I'm Martin Beeby. I'm at the Beebs on Twitter. Who came to my last talk here? Awesome, there's quite a few of you. So if you didn't follow me, though, you can follow me now. That'd be good for you. I'm fresh from NDC this morning, where I gave a talk on Blazor. Actually, it's interesting that you talked about Blazor. Talking about real time and how to host Blazor on AWS, which was sadly at the same time as Steve Sanderson's talk on Blazor. Which Steve's is a good friend of mine, but it was. I was a little bit disappointed when I saw that schedule conflict. It was all right actually. My room was relatively full, so. Yeah, that's what I blame it not being completely full for. But anyway, so I've come up here to Lee Shop. Really loved it last time as well. Like, it's got a great community here. Like, it's a big community for a .NET meetup. It's great that you guys are still doing this stuff and still so active in it. I don't know if I did this last time I was here, but it's become one of the most important slides in the talk. If anyone's got a phone camera, and would be do the honours. I've taken a picture next to this particular slide. This is my inception slide, and you'll see this is me standing in front of a slide, standing in front of a slide, standing in front of a slide, standing in front of a slide. It's actually 42 levels deep as of this morning at NDC, and so that is me at NDC this morning doing this same inception thing. So if you tweet me with a picture at the Beebs or just airdrop it to me or something, oh, get the right side so we can have a proper. I've been a developer since I was 16 years old. And I've been a developer now for 21 years, which makes me, you can work out my age from that, 22. And I work at Amazon Web Services. I've kind of worked in a number of different companies and worked at Microsoft for the longest, and then I joined Oracle briefly. And then I got an offer from AWS, which was something I couldn't really refuse, which was, do you want to work for the world's largest cloud platform and evangelize and advocate for .NET on AWS? And I was like, yeah, I do. Because I was doing a lot of web logic at that time, and I was thinking, I don't want to do that. So it was quite good to kind of get back into .NET, and I've been doing that in a massive way over the last year and 4 months when I joined AWS. So I've had a little bit of a break from .NET, and it's awesome to come back to it and see it sort of flourishing again with .NET Core, stuff around Blazor. It's really interesting stuff which is going on with .NET, and I'm glad to be a part of it again, so it's cool. A lot of people, when I say, and me included, when someone said, well, what about Windows and or .NET and AWS? Like, do people really do that? Is .NET on AWS a thing? And it surprises quite a lot of people to say that, well, we've actually been doing .NET and Windows on AWS since, well, for over 11 years now. So we released our very first EC2 versions, or basically Windows Server 2003, way back 2008-ish, sort of 2009 sort of time. And when it comes to just instances, like virtual machines, as you might call them, we call them instances at AWS, we've had like lots of different innovations and so forth, and now you can obviously get the latest versions of Windows Server, and if you're a .NET developer as well, we have the latest versions of Linux which support .NET and those sorts of things, that you can host your code on whatever sorts of machines that you need to. But that's from a pure infrastructure sort of like boxes thing. We also have a number of innovations which we've been doing over with SQL Server. So lots of our customers use SQL Server, and not only do we supply SQL Server which you install yourself, we also have like a managed service called RDS, which allows you to have a completely managed, highly available version of SQL. .NET, we have lots of .NET things, and this is mainly what I'm going to be showing you this evening. Like, we started off with the very first .NET SDK back at around 2009. So we've been doing it for a long time. We've got lots of customers which are using .NET at huge scale. Customers in the UK like Just Eat, for example, and various others, Skyscanner and various others.
What's X-Ray?
X-Ray is a logging system, so a kind of logger or tracer for your application. So you basically can instrument your application, a .NET Core application, with X-Ray, and you'd like say start trace, end trace. You could capture errors and that sort of thing. And then you instrument your application, and then we have a whole dashboard which basically shows you how your application is operating. So X-Ray is a service that is offered for lots of different things, but we then provided a specific SDK so you can instrument .NET Core applications with X-Ray. And that's fundamentally what we do. The team that I work with, they find what customer pain points are with .NET on AWS, and we build tools, we build SDKs, we build ways of allowing .NET people to access our services. So we have like well over 165 different services at AWS, and all of them can be accessed through .NET. So any of the services we offer at AWS can be used or utilized or built upon with .NET. And then we have application modernization things as well. So if you want to do containers, you mentioned serverless earlier. We've had the longest support of .NET in serverless. We started supporting .NET in 2015. We even support serverless PowerShell. And so there's lots of different things that you can do, not just with standard sort of ways of building applications, but if you're building containerized applications, if you're building serverless applications, if you're using machine learning, deep learning, AMIs, we have all that stuff for .NET too. Is that a fan?
Yeah.
All right, that's okay, as long as it's like good. So there's lots of ways that you can interact with AWS, and the simplest way, I guess, is go to the website. And for some reason, they call it AWS the console, and that confused me because I've always thought it was a terminal was a console. So when people say just go to the console, I was like, oh, you mean the website? So just in case anyone else gets weirded out by that weird naming, the console means the website. And you can pretty much through the console build any service or create any service. Most of them have that sort of GUI interface through the website. I mentioned we have over 165 services. Some of them are obscure. Some of them are not going to be relevant for a .NET developer. Some of them are. For example, we have a satellite ground station service where you can launch satellites or communicate with satellites. Probably not. Most people here are going to require that service. We have a brand new quantum computing service where we allow you to build quantum on real physical quantum hardware, which we have in our data centers, and we have effectively quantum data centers which you can buy quantum compute time. I'm not necessarily going to be doing that with .NET, but that's one of the services that we now offer. We have lots of different things, some of them very niche and obscure maybe, but generally what we do at AWS is we build services which customers ask for. So if a customer or one or two customers have a particular problem or pain point, then that's when we start building services and start building functionality into those services. People like me, my job really is to advocate for .NET inside of AWS. So whenever we launch a new service, I'm the person which will be knocking on the product manager's door and saying, why don't you support .NET? Or what's your roadmap for .NET? How do .NET developers use your service? And making sure that if then .NET developers do use it, that the .NET experience is as good as the Java experience, is as good as the Node experience, as good as the TypeScript experience. We have a team of .NET people at AWS who build .NET tooling. We have teams which build or manage the EC2 instances for Windows. We have teams which are specialist SAs, which are kind of .NET specialists, and they'll go into companies and help them with their, the extreme, the kind of things that they're doing and they want to scale on AWS. So there's lots of ways that we work with and sort of deal with .NET, and it was way more than I even imagined. But this is the 101. If you're going to start on AWS, you'll probably visit the website and you'll click a few buttons, and there's some services you can even code directly into this service. Another way, which is quite common, is so this is the Lambda. If you were to build a Lambda, you can, which is this our serverless platform. If you go in there and you create a new Lambda, then you would you can add what triggers those Lambda functions. You can actually code and write the Lambda directly into the console in some languages, sadly not .NET. You can basically do everything for that service inside of the console. So each service, and we have, I say, over 165, have their own console, and they're all contained inside of the AWS console. You'll note that we have a number of different regions that you can go onto, and so you switch regions when you're inside of the AWS console. So I'm currently in Ireland, so all the infrastructure I'll be building there will be going to the Ireland data center. We have lots and lots of data centers. I won't go into exactly how many, and there's a whole talk on the infrastructure and the way that we build our infrastructure. It makes it highly resilient. We have the concept of availability zones, which other cloud providers do not, or don't do in the same way. But that's a completely different talk. But just so you know, if you see that up the top, that means what data center you're in, and not data center, what region you're in. Because actually a region will be made up of many data centers and many availability zones. So when we say region, we mean like a geographical region which contains many availability zones, which contains many data centers. Another common way you'll probably work with AWS is the command line. So we'll commonly refer it to the CLI, the command line interface. It's built in Python, but don't hold that against it. You can, you would basically do a pip install AWS CLI, and then you can just start writing commands. And those commands, everything in AWS is an API. That's why it's called Web Services, Amazon Web Services. I don't know if you remember, but back in the day, APIs used to be called Web Services. There was this whole thing about a library of web services. That's where the name originates from. And so every service that we generate has an API surface area. And then we build SDKs on top of that API surface area. But you can almost guarantee that we will never launch a service which doesn't have a CLI element to it. So that's like the most base way that you probably interact with it. And you often find that when we release new services, when services are launched internally, I'll often only get the CLI version to be able to play with it. I won't get the console. The console will come next, and then we have the other ways of interacting. Other ways of interact, so this is a command to create an S3 bucket. S3, simple storage service, 3 S's, S3, that's why it's called S3. It's like a way of storing files. And it's interesting, you can store files or information or videos but you can also serve stuff from it as well. So a lot of people use S3 as a way of hosting web content and also websites. You can even attach custom domains to them. You can host websites. We've got a build platform for S3 as well. So it's not just storage, it's also used for like actual serving of content as well. I think I can't remember the statistics, but it's like one of the world's largest storage platforms in the world, and it's obviously, if you go to pretty much any major website, you'll find that S3 is probably being involved in delivering some of that content. But this would be the command, AWS S3 make bucket MB, and then you give it a unique name, you say what region you want it in, and it will then make that bucket for you. And that's like the common sort of pattern that you'll have, AWS service name, command, and then parameters of that command. So pretty much everything you can do in AWS, you can do from command line. I don't, personally, I don't find it, I don't know, I've never been a terminal sort of person. So it's one way you can build infrastructure though. We have tools for PowerShell, which is roughly the same, but we've basically got 1,500 commandlets for PowerShell. Our support for PowerShell has been long-standing, and we've recently actually improved our support. We support .NET Core. I don't know how they name PowerShell now, but it's like PowerShell and then PowerShell Core, which is the cross-platform version of PowerShell. So you can run PowerShell and our AWS PowerShell tools cross-platform. So I can run these on my Mac natively. I don't have to. Doesn't have to be just for Windows. Really, it's weirdly really popular PowerShell in AWS. You get a lot of specifically Windows admins which are really passionate about PowerShell. And the person on my team, Steve Roberts, was actually the lead dev for about 3-4 years on this particular tool. So really cool, and if you like PowerShell, one way of interacting with AWS. Then we have a toolkit for Visual Studio Code. It's like a plugin. You can start working with AWS from within VS Code, which is like the lightweight editor from Microsoft. We have an AWS toolkit for JetBrains Rider. What I found about AWS is you can tell the quality of the service by who they get to present the video. And this particular service is of high quality, as is this one. This is the AWS Cloud Development Kit, and this isn't a toolkit for an IDE like the other two. This is a really interesting new industry trend. So you might have seen infrastructure as code being mentioned before, and you'll see that a lot of infrastructure in code is actually infrastructure as YAML and JSON, which is fine. We have our own YAML and JSON thing called Cloud Formation, which is very good, and it's very useful for people to basically structure the kind of code they've got. But Cloud Development Kit allows you to, in C#, define AWS infrastructure. So I just want to talk to you a little bit about that, because we have bindings for many different languages, but one of the most important languages for me is that we have .NET binding. So you can create infrastructure in .NET using the CDK. And I find it's possibly one of the best ways to create infrastructure in AWS if you wanted to make it repeatable. So let's say that I want to create two EC2 instances with a load balancer. You would write that as some C# code, press deploy, and it would deploy it to AWS. If you said I want to create 5 different Lambda functions with a load balancer and a Dynamo database, and basically construct your entire infrastructure for application, you could define it in code and then deploy it. And that means that you can check this into source control, you can edit it, you can share it, you can create standard ways of building your infrastructure with C#. And so you have to install it using NPM, because the tool underneath is built in TypeScript. And then we have language projection, which projects it into Python, Java, .NET, and a few other languages which are coming soon. And the idea is that anyone should be able to script or code, the infrastructure using the language of their choice. So I just want to quickly show you like a hello world example of this. So if I make a directory, hello world, and cd into that, then we would say CDK, which is the Cloud Development Kit, init, app -- language, and then we choose C#, and then give the project a name, hello world. And what that'll do is just generate like a template skeleton project for me to start then editing and working with. So you have like a cdk.json and a source folder in the .NET template. And then if I do a VS Code, code dot, then it opens that folder up in VS Code. And you'll see there's a solution file in there. You could obviously open this in Visual Studio or Visual Studio Code or Rider or whatever. And then we have basically a C# project. And we have a stack. So this stack represents an entire application. Depending on what infrastructure you might want to build in AWS, you would bring in different NuGet packages. So we have the base CDK NuGet package. This one's an S3 NuGet package because I want to work with the S3 service. And basically the NuGet packages are Amazon CDK.aws.service name. And then some of the services have extra services like deployment. So rather than going to AWS and creating an instance through the console, what we're doing is we're going to start writing or creating our infrastructure in code as actual code, not as pretend YAML code, as real code. And it means that we can do things like we can start doing loops, we can do things that you can do in programming languages which you can't do in YAML. So up the top there, I'll just bring in those NuGet packages. So CDK S3. And then so what I did before I create that S3 AWS S3 bucket, well this is roughly the same thing but I'm doing it in C#. So I'm saying variable new bucket, and then I give it like a construct, this, an ID for that bucket name. And then you have a third parameter which you pass in, which is like the properties which you're going to pass. So there's lots of things about a bucket that you might want to provide information about. So what its ID is, whether it's public or not, and all these different things. And you'll usually find those configurations inside of what they call the bucket props. You don't actually have to provide any bucket props. That would just create you a base bucket with the sensible defaults. But if you then want to construct like some of the different things, you just then can edit it. And obviously, because it's a programming language, you're getting IntelliSense as you're writing. So you can see what the properties of the infrastructure are. I did this in the New York Summit on stage, and we created a VPC with a container, a VPC, a virtual private cloud. We created some containers, and we deployed the containers to ECS with about 10 lines of code. And then that equivalent to write that in CloudFormation, which is our YAML format, would have been 700 lines of code. So there's a big saving in terms of the performance of a language and the way that you're able to make references to different things makes it a lot easier. So here I said I want a bucket, give it a name, change its access control to public read, so you can read anything in that S3 bucket. And then I said that the website index document is index.html, because I'm actually going to serve a website directly from this S3 bucket. So if you're building any Hugo applications or static applications or static websites, then hosting an S3 bucket is a really easy thing to do. We also have a service for that called Amplify Console, which you can generate from the CDK too. There's some security stuff that I have to apply to that bucket. We call these, this is a policy statement. The security model in AWS is based on a thing called IAM, Identity Access Management. And it's different if you're used to the way that, say, Azure works. What you often find is that most of the services or infrastructure have roles or IAM roles, rather than your applications having API keys. So the way that we communicate is by using these roles, and what's good about it is that we can centrally manage the roles and the security from one central place. And it's sometimes when you're using IAM, it can feel a little bit like magic. How's this connecting to this? Like, is it secure? You're not adding usernames and passwords, you're not passing over API keys. They're just able to communicate because you've allowed it inside of the IAM policy. This is a video, obviously, so I'm just going to fast forward so some of this and just show you what I created that policy, and then I added that policy to that bucket. So you do it like a programming language, like I add the policy to the bucket, bucket.addResource to policy. I make reference to that. And you can start making references from other things as well. So let me go a little bit further along. I create a bucket deployment. And what I say is I want to take a local folder on my machine and do a bucket deployment to that S3 bucket. So what I can do with this is say the source is going to be an asset local on my machine. So I give it a source folder. Let me just skip through a little bit. So I say there's a folder called .site contents, which I want to take the asset from. And then this last bit is a CloudFormation output. And basically what that will give me is the website URL for this particular bucket. So I've basically built a bucket, I've added the security policy to that bucket, I've then made a deployment from my local machine to that bucket, and then I've asked the CDK to output a URL once it's deployed to this application. It's a really simple, straightforward application, but it's going to make it very straightforward to then deploy from my machine. And what's cool about it, it's repeatable. I could put this into a CI/CD pipeline and deploy it, and it would work the same every time. So I create a HTML document, and then I use some magic HTML, obviously expert HTMLer. So this is inside that site contents folder. So what the CloudFormation is going to do, when I say CDK deploy, it's going to basically wrap that up into a zip file, and then it's going to deploy it all to what we've got our CloudFormation service, and it's going to start building our application. So if I go to the terminal inside here, I can type something called CDK synth. And what CDK synth does, it takes all the code, compiles the application, converts it into a thing called CloudFormation, which is, if you're from the Microsoft world, that's like an ARM template, like a description of the infrastructure. So you'll see this nonsense is all the YAML which would have been required to describe that thing that I just created. And actually that's physically what we do deploy. We deploy a CloudFormation script. So we generate it using Cloud, and then we deploy a CloudFormation script.
Is that what you mean when you said we project to different languages, or is that something else?
No, that's slightly different, is that basically we write the CDK in TypeScript, and then we allow you to use C#, but under the hood it's using TypeScript to actually do the generation. So that's language projection. So then I say CDK deploy, and what that means is that in my current account, in my current region, it's going to deploy that S3 bucket and that stuff for me. And the cool thing is, at the end, it gives an output, which is what we asked for, which is a URL. If I click that URL, it's going to go and take me to a website saying, oh my god, this is live, right? So we are doing a really straightforward thing here, taking some HTML, but of course, we could take a Docker container, containing a .NET Core application. We could take and put it onto a Kubernetes cluster. We could put it onto ECS. We could put it into ECR, our Docker container registry. You can do everything through, or most things through the CDK. It's one way of interacting with this. Right.
Yeah. Are there any measures in place for people accidentally, going into a recursive function and, newing up?
What an endless loop for
having some Mandelbrot Amazon.
Well, obviously, there's a point when you say CDK deploy, it does generate a CloudFormation script for you. So like, if you were to generate millions of machines, you would end up with a very, very long script, and I imagine you'd have some issues with that anyway. But no, there is infinite, there's quite a lot of scale. There is one thing protecting your AWS account, which is important, is you can actually set a spending limit on how much you're allowed to spend.
I suppose you don't care, right? I mean,
I don't care, no.
Amazon doesn't care, right?
No, we do care. And if we do really care, if you ever build something accidentally and put it out there and it costs you lots of money, all you have to do is open a support ticket and they will refund you. I know that firsthand because I created a secure FTP server and left it open for 6 months on my personal account by accident. It costs quite a lot of money, hundreds of pounds a month, that particular service. And I was speaking to one of the SAs and he said, just open a support ticket and tell them. What they did was they monitored, they looked at the S3 and made sure that I wasn't using it in production, and then they refunded it. And I actually asked, could I have the last month? And they actually went back all the way to the beginning of the account creation and gave a refund of it all. They'll do that as long as you're not maliciously doing it. If it's an accident, if you're generating expensive resources accidentally, we wouldn't charge you. We would make sure, just open a support ticket and we'll fix it for you.
Just to back that up, my mate actually followed your tutorial for the free trial.
Yep.
Run up a 4.5 gram hill without realising. Because he forgot to turn off all the services, and contacted them, they refunded the whole lot.
Yeah, they will, because it would be,
Not used it, don't worry.
it would be completely stupid for us to charge you for that.
Yeah,
Yeah, and we don't like. The other thing is that we do have a scale. We do have a scale. We are capable of scaling to really large of doing stuff. But most accounts, when they're newly created, actually have soft limits. So you have a limited amount of numbers of EC2 instances you could create. So you'll probably hit one of those limits. If you tried to create 1 million machines, for example, you couldn't really do that unless you were a company, which we've raised those limits for. You can actually view the limits that you currently have on your account through the console. But so there's a few different ways. One, you can protect yourself by saying never alert me or never let me go over this amount of money. And the other thing you can do is that we have limits to stop you generating huge quantities of stuff. So we have this AWS toolkit for Visual Studio. You get it. This is for Visual Studio 2019, 2015, and 2013. You get it by typing in AWS to the Visual Studio extensions gallery. Lots of people use it. This was taken quite a few months ago. We've got 1.2 million downloads of the toolkit, which makes it one of the most used. It's a V6 package. I always used to call this a VisX package, but I've been reliably informed by the Visual Studio team that's called a V6 package, which is the extension mechanism for Visual Studio. Sadly, it's not the extension mechanism for Visual Studio for Mac. They have a completely different extension system, and we don't have an extension for Visual Studio for Mac currently. We're hoping we're probably not going to build it. We're hoping that they're going to change their extension mechanism so that they can support Visual Studio extensions on Mac as well. That's what we've asked them to do anyway. I don't know if you know the history of Visual Studio for Mac, but it's actually Xamarin Studio. So it's a completely different code base, which they've over the last 4 or 5 years been like aligning and making one. So once you've got the AWS Explorer installed, you will, inside of Visual Studio, have a number of different things that are enabled for you. So this is just another way of working with AWS. You can choose, use the SDK, use the CDK, or use the tooling inside of Visual Studio. We're trying to make it as easy as possible for .NET developers to use AWS. So I add my account, and you'll see you can add numbers of accounts, many different accounts. If you already use the CLI, the accounts will be already here, the profiles will already have been created for you because it's using the same profile system. And it basically has a list of the most commonly used services for .NET developers. So this is a DynamoDB service. It's a NoSQL database service. And you can go in here and you can do some rudimentary things with some of the services. So with EC2, you could create an EC2 instance directly from here. With DynamoDB, I'm able to add records. I wouldn't recommend editing your database like this inside Visual Studio, but it's quite good for testing and just having a quick look at some of the tables. You can do a basic search and things as well. So I've just added a couple of records to that DynamoDB table from directly within Visual Studio. It's quite cool. DynamoDB is like a really quite cool NoSQL database that I've been using a lot recently. So we can say Martin, age 21, as we discussed. Jeff, age 35. And then I can do a scan on that table. And a scan is basically a search on that table, so I can say where the name is equal to Jeff. And contains Jeff. Scan that and it will just return that one record. So if you want to dip into your tables and have a look at them, you could do that. Here you can see all the EC2 instances which are running, Elastic Container Service, S3. You can add items to your S3 buckets from directly within Visual Studio. We've got Lambda. We can even add users to our Identity and Access Manager for AWS from within and create users and things from directly within Visual Studio. So we've tried really hard to put the stuff that you might need or commonly use, .NET developers, directly at your fingertips inside of Visual Studio. Visual Studio tooling is the best of all of our tooling in terms of IDE support. VS Code and AWS for Rider are a little bit more around serverless application development, not really all the things that we support here. When I came to AWS, the first thing I was like, I need to host a website. Like, how do I take a .NET application and get it live? And so I had a .NET Core application, which I moved to Elastic Beanstalk. And actually, it's one of the projects that I was working on for my NDC talk this morning. I was using a lot of Elastic Beanstalk to do some of the Signal R stuff, which Blazor requires. But Elastic Beanstalk is quite an old service. I think it's been around since 2010. And it was one of the world's first cloud PaaS services. So this predates any Kubernetes or container systems or anything. And the concept is, you give us your code, we then deploy your code onto servers, which we will manage for you. We manage the servers for you. If they fail, or we'll restart them, we'll rebuild them. And if you ask for 3 servers, we will give you 3 servers. And if one of them dies, we'll replace that server, we'll redeploy the application. But basically trying to keep this cluster alive and your application deployed. And we give a mechanism to make it really easy to update the application. Beanstalk supports lots of different platforms, but .NET's one of them. So you can build like Ruby on Rails applications or Go applications or PHP applications, but it also supports .NET. And we support .NET older versions and all the way up to .NET 3 Core 3.1. We announced 3.1 support very like a couple of weeks back. So it's constantly being innovated and stuff. It's quite an old service in many ways, but it's one of the easiest to understand if you've not dealt with Docker containers or anything like that before and you just want somewhere to take your application and put it. You could, of course, create an EC2 instance, log into that EC2 instance, install whatever you need on that box and manage the box yourself. But this is kind of like a way of managing the boxes for you and makes it a little bit easier. It also manages things like the load balancer. So you can say, I want 3 instances and a load balancer, and it will set the load balancer up and point it to the 3 instances and do the stuff to make that work. So to create a website inside of Visual Studio, we just do it exactly the same way we would do any sort of regular website application creation. This same thing will work in Visual Studio 2015 as well. So if we search up here for AWS, you get all the different AWS project types that we offer. But we don't need an AWS project type, we just need a standard .NET Core application. So I'll create a web application, just a standard .NET Core application. Might be empty, which is never empty, or a web application, we'll create that. Now, what our tooling does is it's smart enough to recognize that project type is of a web application that could be deployed to Elastic Beanstalk. So we have this little button here now which says, well, that could be deployed to Elastic Beanstalk. So you right-click it, you choose the region you want it to deploy to. You say, I want to create a new application environment, a new cluster of machines. You choose things like what the URL, the base URL is going to be. Of course, you could add custom domains and SSL certificates, and that's all part of the service as well. I choose the container type, which is going to be running on, so I can say I want to run this on Server 2016. We do have 2019 support as well now. You can say the instance type, the type of machine that you want. We have many different types. I'll put on a T2 micro, but there's lots of different types that you could choose. And then we give it a security key. And this is a key pair. We don't give you the username and password for the server. But I want you to understand that these are just servers. What it's going to be creating are just servers. It's just going to be managing them for you. But then I apply a role, and that's the IAM roles to that service. And that's what allows me to, if I want to connect it to another AWS service, I would use IAM, that IAM role which is attached to the machine to give that particular machine or that service access. And then, excuse me, then we can just go and take that and then deploy it, and it would deploy the application over to our website. So after a while, 2.5 minutes, it will get this screen, which will give you all the information about its deployment, and then you'll be able to click the URL, and that Elastic Beanstalk is there. It's a load-balanced .NET Core application sitting on AWS. We can also connect to the instances that are running. Now, this might happen that you just want to see, and I'm only showing this to show you that we're capable of actually logging in or RDCing into these things. Now you notice that when excuse me, I tried to connect there to the remote desktop connection of that server, and it failed on me. And the reason it fails is because the port for remote desktop isn't open by default. Now, ordinarily, if these were just machines which you managed in your own data center, you would have to go to each machine and you'd have to open the ports on the firewalls to allow the port access and so forth to be able to go and get that, right? To be able to get access to that particular port. In AWS, we have this concept of security groups, and security groups are basically a firewall, effectively. And you say, for all these instances, any instance you create, you have to assign it with a security group. So for all of these instances in this particular service, I'll assign it a security group, and that security group will be applied to all of the machines which are in that security group. So if I open a port on the security group, it will open it on all those machines. And it means that you can have a cluster of 20 machines which are load balanced, and if you just want to open one port for that cluster of machines, and you want all the machines to be open, then you would just need to change it to that one security group, and then it would be applied to all of the machines. So we're going to add the RDP port to the security group. We can do that from within Visual Studio. So in the AWS security thing here, we have security groups as part of EC2. Here's the security group that I use for my, my Elastic Beanstalk instance. And I can just say, add a permission to that security group, add a port number, RDP. It will then apply that to the security group. I'm adding inbound and outbound, but you don't really need to. So it's adding port 3389 to it, and then that port will now be open on the security group, which means that any instance which belongs to that security group or references that security group now will have that port open. So I should be able to now go into the system here, connect to the instance. I'm using the EC2 key pair. I don't add a username and password to connect to that instance. And then, boom, I've got actual access to the physical machine if I so wish to have it. Something managed by Elastic Beanstalk, you probably shouldn't go into the server and do this. It's being managed for you, so it would be silly to go and mess the machine up. But just to show you that it is just physical hardware, you could actually go and access it if you want to, of course. And it's just running, this particular one's running IIS, and it's running your applications. Obviously, you could have instances which were Linux running .NET Core, and you could configure them to run .NET Core applications if you wish. But there's no magic. That's what I want to try and get across to you with something like that. Most of the infrastructure at AWS is built up from instances. The other kind of, if you want to just work in a world where you're building with from Visual Studio and you want a very simple way of uploading a .NET application to AWS, but maybe you've got containers, a Docker container. Well, we have ways of dealing with that as well. We're going to basically take an application, we're going to add Docker support to that application from Visual Studio, and then it's going to allow us then to deploy that container to one of our container services. One of our container services is called ECR, Elastic Container Registry. It's basically Docker Hub for Amazon. So it's a private repository for your Docker containers. So what you can do is go into a project, and you'll notice that I've only got publish to another cloud provider or publish to AWS Elastic Beanstalk. What you can do is add a Docker support. This is part of Visual Studio, this isn't any AWS tooling. And you say, what's the target OS, Linux or Windows? I chose Linux because it's a .NET Core application that I want to run on Linux. And then it created a Docker file for me in the solution. If I click on that Docker file, it's got a two-step multi-build Docker file, which is going to basically create a container for me. It's going to build from an image, and then what it's now noticed that this is a container application, so I could publish it as a container to AWS. So I can say I want to publish this application as a container to either an ECS cluster or to Elastic Container Registry. So I'm just going to push it to the Elastic Container Registry. We've got lots of ways that you can event. Once something's uploaded to a container registry, we can set an event to build a pipeline, which then goes and deploys that to one of our container services. We even do things like when you upload it to the container registrar, we can scan the container image for vulnerabilities and security vulnerabilities. So we have a whole process around that as well. We can even do stuff like when you can set alerts with EventBridge that when anyone uploads or deletes a container from ECR, that you get a message or an event happens or a Lambda function's kicked off. And that Lambda function could flash your lights in your office to say someone's deleted the container, which is really important for production. Everything is automatable in AWS and everything is eventable. You'll hear words like EventBridge, and I recognize I've been speaking, if you're not familiar with AWS, about tons of different new, unfamiliar services, and it's kind of, there's a lot in AWS that they do. But just know that you can pretty much automate anything in AWS, and you can pretty much have an event for anything that happens. So if you want to be sent an SNS notification to your mobile phone when something happens, when someone deletes a container from your ECR repository, you could make that happen. If you want to click off a Lambda function, which then instigates a whole deployment process, then you could do that. If you want code pipelines to kick off based upon a check-in to a code repository or a check-in of a container, you can do that. Once you've got your container and you put it somewhere, Docker Hub, ECR, wherever you have your container, you might then want to deploy it. Now there's lots of options now in the world of how to deploy a container. So a Docker container can go to Amazon Elastic Container Services. This is the original container service at Amazon. We built it, we run Amazon.com and all the different things on this service. It's highly scalable, it's used by some of the largest websites and applications in the world, and it will not let you down in terms of reliability or availability. And you can run on it .NET Core on Linux, .NET Core on Windows, and .NET Framework on Windows. So you can use old Windows applications, which are Windows Docker containers. They can run on ECS. .NET Core for Windows can obviously run on ECS, and .NET Core on Linux, of course, can run on ECS because it's a Linux container, and Linux containers run everywhere. EKS, which is the Amazon Elastic Kubernetes service, is using the open source Kubernetes container engine, and we are allowing you to deploy to that. So really the choice is, well, do I want to use the thing that Amazon built and have been offering for a long time, or the thing that Amazon built on top of an open source project because some people want to use the open source thing, or they might already have a Kubernetes cluster and they want to move it to the cloud. So we created the EKS service. It's the world's most popular Kubernetes service. More customers use our service than anyone else for real production workloads. I think we have something like 78% market share of Kubernetes, which surprises a lot of people because there are other cloud providers which you might think would have bigger Kubernetes than they do. But we have quite a lot of people running real-world applications on this already. And you can take your containers for .NET Core on Linux, .NET Core on Windows, and now we support .NET Framework on Windows containers. I think we are the first, and I still don't think any Kubernetes supplier offers the ability to run Windows instances or Windows nodes on Kubernetes. We're the only one. I think Google might have it in preview, but I think we were definitely the first to have a GA service. And then we have another interesting one on the end here called Fargate. This is where stuff gets confusing. These two services require you to create a cluster of machines, which is then the service is deployed to. Fargate, we have a cluster of machines. We maintain the cluster of machines. You give us the container and run it on our cluster of machines. We call this the serverless container platform, in that you don't have to manage any of the servers. You just give us your container. You tell us how many instances of that container you want, and we'll run it for you. The reason it gets complicated is, as of last month, you can now have EKS with AWS Fargate. So it means that all of the underlying infrastructure actually runs on top of Fargate. So it's a serverless Kubernetes. Again, we're the first people to have a serverless Kubernetes. Just sometimes, it's genuinely for customer reasons, but sometimes it does sound like we just want to try and add as many different names together and make it quite confusing.
What would run on Fargate? What's a
the business case for that one?
So what's good about that is that you don't have to manage any of the infrastructure. So if you've just got a container and you say, I want to scale this container, but I don't really want to manage the machines, or I don't even want to set them up or pay for them, I just want to pay for when the container's live, that's what would be beneficial there. But AWS to Fargate only runs .NET Core on Linux, because it only runs Linux containers. We don't have a pool, in our pool, which we run Fargate on, we don't have Windows nodes, so we can't run Docker for Windows on those. So if you've got an older .NET, a containerized version of SQL Server, or if you've got a containerized version of a .NET, ASP.NET 2 application, you'd have to run that on Docker for Windows, and that would have to run in either EKS or ECS, but you wouldn't be able to run that on Fargate. It has to be a Linux container to run on Fargate.
Are there any cost implications between
Yes.
the three?
Yeah, there are. But I'm not going to get into it. It's like, it's not...
Is this the cheap side or is that the cheap
It
side?
depends. It genuinely depends on the scale of what you're doing. And there's difference between these two in cost. There's differences between, largely saying, with the serverless model, generally speaking, serverless model will work out cheaper because you're only paying for what you consume.
Yeah.
Whereas this, you have to have infrastructure sitting around all the time. Whereas that only has infrastructure. So if you're using containers to do like dev test, and it goes up and then it goes down, like Fargate would save you a lot of money because you never have to have the nodes which are managing the containers live. So
Are you managing how many instances you want to put live, or would it notice that it's getting really hammered, let it fire a few more containers?
no, you would say how many, you would like add a task definition to say how many containers you want, and we would maintain that number of containers. Like we would maintain that sort of number of containers. We're effectively running, Fargate is a run mode on top of ECS and EKS now. So we're running these in the background. So we have to have the infrastructure always live, but you're only paying for it when you're in need of it. But that does mean that if say you want just massively increase the number of containers you want to support, you don't need to add new machines. You can just scale. I want 20 of those containers today. I want 10 of them yesterday. I want 20 of them today. And all of a sudden, they'll just increase.
Right, so we've got to be the ones to say, I want 10 more, rather than it going, hey, there's a sudden influx of traffic. You've already told me I can go up to this.
We have a thing called auto scaling, which is as I say, with everything you can automate things. So you can automate that mechanism of scaling, and all of these different container services have different ways of doing of scaling. So ECS has an auto scale model which can add machines to the cluster, and then that increases your capacity. You can have auto scaling with Fargate when you notice lots of traffic coming in. You can update your Fargate service to change the task definition. So there's ways that you can scale all of these different things, but we don't do anything unless you'd have to set up scaling. But there are.
But it's possible to set it up.
Yeah, it's not like you'd have to write loads of code to do this. These are features of most of these container platforms that you can set up scaling. And that's true of ECS and EC2 and all those things as well. You can have auto scaling groups which basically say, I've got an ECS cluster and I want to scale up based upon just memory and CPU. With ECS, we now have a method which says not just CPU and memory, but actually looks at the containers themselves and does auto scaling based upon the container workload. So there's lots of complication in that, which I'm probably going to avoid if that's all right.
Yeah.
You can, and you
just very high level. It's possible. Yes, good.
The third way you might run .NET Core on AWS is serverless, and we've mentioned that a little bit. Are people aware what serverless is? Basically, creating a piece of code as a function. So let's see over here. If I wanted to write a function, it would be something like this. Right, so C# lambda, a function, there's a function handler with an input, a lambda context, and all this function does is input to upper. Now, if you're wondering how I did that, I'll tell you in the pub, but I didn't actually type all that. But that is real Visual Studio, that's not video. This is a really sort of bare bones lambda function in C#. You can't see it particularly well if I just zoom out into it a little bit there. And what you can do is this function can be evented any way you want. So if a URL comes into a service called API Gateway, that could event this Lambda function. So that would be like going to a URL and then calling this, and then that would return something. And you might return a 200 or a JSON package or something like that to that service. This could be an event when someone presses an IoT button that we sell. You could kick off one of these Lambda functions. This could be evented by a build service. This could be evented by a GitHub action. We have lots of different ways that you can trigger a Lambda function. And then not only can you trigger Lambda functions, you can also chain them or build them into workflows using step functions as well. So there's lots of cool things you can do with serverless. And the Blazor application that I built this morning, I was using serverless functions. And what was cool about it was I was building a real-time application with WebSockets and API Gateway and WebSocket support. And people were able to do live voting on this application. And every aspect of that entire application was serverless, meaning that I only pay for the computation of people actually executing stuff in my application. When I stop going to a conference and they're not voting in this application, that costs me nothing. It costs me a little bit for the storage in S3, but it costs me nothing else. And what's cool about that is that Lambda functions don't cost you anything unless they're executing, and they're built by 100 millisecond intervals of compute. So you get 1 million invocations a month for free, and if you want to scale more beyond that, then you'll be paying based upon the numbers of requests that you put through. But what we're finding is that people are taking stuff which requires big machines which sit there being underutilized, and they move to a serverless model where, especially for kind of workloads which are spiky or infrequent, you can save an awful lot of money by doing this. So I believe Comic Relief, for example, Comic Relief used to have an application which was server-based, like a standard sort of regular web, full-stack web application. And they moved to a serverless model for all of the web front end and all of the payment services, and they were reducing their costs by 93%, their hosting costs. So I think it was something like, for the night of Comic Relief, something like £80,000 was their regular hosting costs, and they got it under £5,000 the last Comic Relief. So you can make some serious, especially if you've got really spiky workloads. But then they're really useful for like eventing, like things happen here and there. We use this at Amazon and AWS to build lots of our services on. So you will find we're one of the biggest users of Lambda. It's a really interesting, really interesting world, and I encourage you to look at serverless, even if it's not on AWS, even if it's on another cloud provider. Yeah.
What's the warm-up time for it? So if I don't hit it for a long time,
the warm-up time. So with .NET, what's actually happening is when you do a thing called we call it a cold start, which what happens. Imagine how it really works, right? We have a pool of infrastructure which we manage, and on that infrastructure we take your code. So every time a request comes in for an event, that triggers the system, and the system says, well, I don't have that code on any machine. So it has to take the code, put it on the machine, instantiate it. It puts it into a thing called a Firecracker virtual machine, which is a security boundary. It's effectively a micro virtual machine. And then that would be then taking requests coming in. Once that gets swamped, like it's too much for that one container, we would then add more and more micro virtual machines to handle the load. So you have, like maybe you have 10,000 transactions per second coming into Lambda, then we would obviously have to scale our infrastructure to handle that. But that's what Lambda does, that's the point of it. And as the traffic goes away, we would massively reduce it. You don't pay for any of the scaling, you just pay for the invocation, compute for the invocation. So a cold start means it has to copy the files over, has to build it in C#, it has to do a compilation. You will find that a cold start in C# takes around 500 milliseconds. And then once it's live, you will get like sub 100 millisecond responses. In fact, .NET is one of the fastest Lambda runtimes once it's fast. We've just announced a new feature in Lambda. Because some customers said we can't tolerate them ever going cold, we want them to always be live, which is sort of defeats the object of serverless in some ways. But let's say you want to have provisioned concurrency or provisioned resources to manage 10,000 requests. What you can say now is I want to be able to always manage 10,000 requests, and then we will provision that and always have it live for you, so that you never have a cold start. And that gets, some of the customers which we had were doing like heartbeats to the Lambda to try and keep it online and stuff like that, doing all kind of crazy things to make sure it never went cold. And it's all an anti-pattern, and it was not ideal, but this is a way that those sorts of customers which really cannot tolerate latency can still build serverless applications. And you will find that with serverless generally. When I started in serverless, it was noddy examples and silly little things. Now we're talking about re-architecting major applications. Lots of companies are doing it very seriously, and all the sorts of problems around invocation and scalability are all getting solved. So you can build any class of application, and I'll show you a few classes that you can build.
The thing that you just mentioned there is obviously an additional cost, right?
Oh, sorry, provision concurrency, yes.
Yeah.
Obviously, we actually have to provision some infrastructure, so there's a cost to provision concurrency.
But it's still obviously
it's
a lot cheaper than...
Well, most companies don't need it.
Yeah.
Most people can tolerate cold starts. Some people can't. Some types of applications can't, because basically, what would that mean, a cold start? Well, roughly, let's say every 5,000, let's say, and this isn't the right number, but let's say every 5,000 calls, one of them is slow.
Mm.
That's okay for some applications. It's not for others. If you've got, if your Ring doorbell, I don't know, if your Ring doorbell and someone rings the button on that door, that invokes a Lambda function somewhere. That's how that IoT thing, that's how it's getting. Now, the latency of a few hundred milliseconds probably doesn't matter, because the latency in actually getting your phone out of the pocket and checking them is longer than that.
Yeah.
So, but if you've got you might have an application where it does matter, and that's the
Sells tickets or something like
Flies a helicopter. And turn left.
Yeah, don't do that. Don't do a control system for an aeroplane on Lambda.
that.
That would
I'm obviously not asking you for concrete numbers, but in terms of, it must lie between having just having a normal machine and not having a Lambda function in terms of cost.
So there's absolutely
is like a small percentage increase or something like that if you
Oh
want
no, you mean provision concurrency?
concurrency.
No, it's way cheaper still, because even if we still don't have to provision you a whole whole machine to do that.
Yeah.
We just basically don't kill your instances, So we've worked on the model so that we can make good money out of it, and it's not off the top of my head I can't remember how expensive it is, but it's nowhere near as like you're not paying for our always live EC2 instance. And you only say, it's the provision concurrency, so you say how much concurrency you want. One thing I will say is that it's often said in serverless, we say, yeah, I can scale infinitely. That isn't necessarily true. If you go and try Lambda and you DDoS it and see what happens, you will find that you get service limits where it says actually it won't do any more. They are soft limits usually, and we have customers which can do massive amounts, but you have to ask for, you have in your control panel for Lambda, you say how much scale that you want to go to, and that the reason for that obviously is one of cost saving and one of you never have to do capacity planning with AWS, but my God, AWS has to do capacity planning. So there are certain limits. You'll find this with all the services. None of them are infinite. Some of them can be infinite, and you can get it lifted if you have a requirement. You just need to speak to your account manager or to open support tickets to get. But just to mention that, because some people just assume that, oh right, well I could go from 0 to a billion requests, and that's not actually true. There are physical machines, there are real physics involved. So I just showed you a 2-upper example in Lambda. I want to do something really more complicated, so I want to create a more complicated API. So I thought I'd try and solve a big problem, the meaning of life, the universe, and everything. So if you're not familiar with the Hitchhiker's Guide, the almighty answer to the meaning of life, the universe, and everything was calculated by the computer deep thought for 7 million years, and the answer was 42. So I thought I'd make that into a Lambda function. So to do it inside of Visual Studio, we go File, New, Project, and this is in Visual Studio 2015, and I say I want a Lambda project. It gives me some options of some templates. If I create an empty function here, it's going to create that project for me. And you can see I've got that C# folder file. And here we have our function handler. A function application doesn't have to have one method, by the way. It can have many. we just always, like as a simple example, we'll put one method in there. But it can have NuGet packages, you can have different calling in different classes. So I'm implementing the meaning of life. Ba-ba! It's a much more complicated Lambda function. We can run it in a thing called the mock Lambda test tool. We don't always want to deploy directly to AWS. We might want to test it. We might be on a plane or a train not have connectivity. The mock Lambda test tool in Visual Studio allows us to execute a functional input against that Lambda. Here, I'm just going to be sending a string. But depending on what invokes a function, it will send a different, potentially a very different package. So I've invoked it with a string, and it's returned 42, because that's basically what that Lambda does. So you can test that and run it locally. We've not deployed anything to the cloud at this point. We're just running this locally in Visual Studio, and all of that will work offline. So now to deploy it, we do the same dance as we did before. All of this could be done at command line. I right-click, I say publish to AWS on the project. I give my function a name, answer 42. I say what region I want it to be in, US West Oregon. I say what framework that I want to use, which is, it's a .NET Core framework always. We support 2.1. We don't currently support 3, because 3 is not a long-time an LTS release. 3.1 is an LTS release, and we will soon support 3.1. You can actually bring your own custom runtime if you need 3.1 or 3, for that matter. But by default, we don't have those sort of runtimes supported. So we're publishing this now, and what will happen is our function will eventually get published, and we'll get this new sort of like UI inside of Visual Studio, where we can do the same sort of thing, where we type in an input, and then invoke it, and it will execute against the function. What is the meaning of life? Invoke it, and the answer comes back as 42. What you see at the bottom now, because we're actually executing it on a real system, is that particular function had a 0.36 milliseconds of compute was utilized, and we were billed 100 milliseconds.
Oh, what?
I know. Billing happens at 100 millisecond increments, which is tough.
Is that AWS profit margin?
Yeah. So basically, you need to make your code more efficient to the point of, if that had been an extra 64 milliseconds worth of compute that we're kind of swizzling you out of in a way. But that's what is actually quite amazing about some of these things, is that we used to talk about per second billing for stuff and be really impressed by it. We're getting to the point now it's 100 millisecond billings for computation. A Lambda function by default will run for a certain amount of time. Sorry, yeah.
Sorry, just to clarify, that 100 seconds, is that per request, or can I get 3 requests into that same 100 milliseconds?
You'll build, no, you can't. So it will be a single invocation is going to cost you a minimum of 100
Gotcha.
milliseconds.
99 milliseconds, no less.
Yeah. I don't think you could,
Timed up.
you could try, but I don't think you could actually physically optimize your functions to always guarantee 100 millisecond utilization. But
there's a tool in there somewhere.
That's roughly what that's doing. When we're talking about the costs for this sort of stuff as well, Lambda is ridiculously inexpensive for this compute. So we'd be talking about 0.0000000 lots of noughts 9 of a dollar for that sort of level of compute. That's the amount of memory that used. It was using 256 memory. There is a limit which you can increase or decrease per Lambda function. So you say how much you will tolerate. If your Lambda function goes over that memory limit, or goes over it, basically it will stop, the function will stop, or would basically crash out an event that it went over the exceeded memory. And if it goes over the allotted time, you can set the allotted time for it. It used to be 5 minutes, I think it's now a maximum of 15 minutes, but it might have been increased, I don't know. And basically you can run a Lambda function for it. So you can't run a long running job on a Lambda. It can only be something which is invoked for, say, 5 minutes, 6 minutes. If it goes over the allotted amount that you've said for that Lambda function, then it would just be stopped. The execution would be interrupted and stopped. So when you're building serverless applications, you obviously have to guard against those sorts of things, like those instances which are happening. The cool thing is all of this login is happening with a thing called CloudWatch. So if you want to go and inspect all of the logs for this, you can just go onto CloudWatch and see like when it started. Anything you console log, right-lined or console.right-lined would appear in this log output. And that would be, you get basic raw logs in CloudWatch, but you could also you could also send all your logs to a log, a more detailed log system for searching and stuff, to Elasticsearch maybe or something like that. So that's a Lambda. There's lots of different use cases for it. I just want to show you one which is kind of freaky, and this was built by one of the engineers in our team, which made me like really go, how the did you do that? Basically, he took he was saying, well, if you think about it, a Lambda execution is a little bit like an MVC route. So he said, what's stopping us basically building a Lambda application, an MVC application, a web application, and then just making all the MVC routes Lambda functions? And I was like, all right, Norm. So you could build all these sorts of back-end web applications, data processing, chatbots, Alexa applications, IT automation. IT automation is a really popular one. For example, PowerShell scripts, which run arbitrarily on a timer, or PowerShell scripts that run. There's one which is I've seen someone do, which basically just checks the security groups. It's a PowerShell function which runs every 10 minutes. It checks the security groups in the entire account, and if there's ports open which are not meant to be open, it closes them. That's like an example of really common automation that you might do in PowerShell, and that's why the PowerShell Lambda functions are there as well as C# ones, because IT admins, not just developers, are using these sorts of services. Data processing, real-time, MapReduce, those sorts of things can be done with Lambda. There's lots and lots of use cases. So this is an example of creating a website, a .NET website using Lambda. I'm not recommending this as an option, I just think it's cool. So we've put it in as a sample, so you can say AWS serverless application and you choose an AS.NET Core web app. Okay? And what it's going to do is create a template for you. It's modified 3 files from the base template. It looks just like a .NET Core MVC application. MVC routing works just the same way as you'd expect it to. But it contains this file called serverless.template. You'll see we have a slight modification on the entry point. We have 2 ways of starting it up. One is the startup, which we use when we're processing via Lambda, and one's the way we start it up if we're debugging it locally. We have this serverless template, which basically maps the methods in our application. That is a thing called SAM, which is another way of describing infrastructure in YAML in AWS. There are 3 ways. SAM is a cut-down version of CloudFormation. So what we can do is... Oh, I thought that stopped, sorry. We take that serverless application and right-click on it and choose to deploy it. And it deploys what we call a serverless application, which is more than one function. It's a collection of functions, and maybe a gateway, and maybe DynamoDB in a database. All of the structure was defined in that SAM template, that serverless application manifest. And we say, give the stack a name, and we click publish. And what it does is it compiles all my Lambda functions, uploads them. There's more than one Lambda function. There's a thing called a gateway, an API gateway, which has been set up. It's created a few different pieces of infrastructure for us. But what's cool is now I have a URL. If I go to it, it is a .NET Core application. And every time I'm going to a route, it will work exactly like an MVC application. I'm paying every time I execute a route, which is why I'm not sure that's a great idea, unless you had one of those websites that you built for a client which never gets visited. You know? And I've got a lot of them, like sit on my servers, no one ever uses it, but they're paying for a virtual machine every month. We'll take it off that virtual machine, put it into this instance, it will be responsive, highly scalable, but when the 5 people which visit it that month, you'll only ever pay for 500 milliseconds of execution and nothing else. Interesting model of building MVC applications. It's a bit of fun, don't use that in super production. Just use it on the websites that are not important. There's a few different features in Lambda. There's this concept called Lambda layers. Lambda layers is this ability to, when you deploy the function, You might also want some additional stuff which goes along with this. Different languages, it's easy to add. There's reasons why on other languages this is more obvious. Dynamic languages, for example, where you might want to take packages or have supporting third-party libraries which are deployed outside of the function. Lambda layers are basically in the .NET world used to add support for caching NuGet packages and things like that. So there's some examples of some of our customers which use it to Lambda layers to cache NuGet packages. You probably won't need to use them too much, but one of the cool things about Lambda layers is that one of those layers can be a runtime API. And what this is enabled is we have a number of languages we support de facto. So we support .NET, Java, Python, JavaScript, or Node. But we don't support languages like PHP because it's 2020. And so, but there's people which want to build, lots of people which want to build PHP applications with serverless, and they would like to utilize PHP. And I've been told that PHP is actually quite a good language nowadays. I've not used it since 2009, but I mean, I've been told it's like now it's like object-oriented and stuff like that. And so there was this company called Stackery which was like, we would love to build Lambda for PHP. So we gave this concept of a runtime API, which means that you can take any language and basically embed it in such a way that we can now execute any language in Lambda. And our customers and the open source community have then contributed PHP, COBOL, of ways of executing Lambda functions. I think that one's more for fun. There's a project on GitHub called Awesome Layers, and lots of these are in there. What it means for a .NET developer, though, is that we can run in Lambda unsupported versions of .NET. So at the moment, we don't have .NET 3 support. If for some reason you needed to write a function and it had to use .NET 3, you could use a custom runtime to run that. And I just want to show you a little bit about what that is. Inside of Visual Studio 2019, I recorded this a little while ago, so I used .NET Core 3 rather than 3.1. I will just create a regular AWS project, but in the blueprint, I'm going to create, instead of choosing like an empty function, we've got a template called a custom runtime. And this just allows us to add one of these layers that I was talking about. So a custom runtime function. These are all helpers, by the way. Everything that we do in Visual Studio is ultimately executing against the CLI. You can do everything that I've shown you here in commands or a scripted language. So it gives you a sort of boiler template here, and I've got a main entry point to our application. And that's the big difference. Like before, you see that we came into our .NET application as a handler. One of the things with the custom runtime is it comes in as a main, into the main function. But then ultimately I change it to go into the function handler. So this is that same function which does a to upper. Now what I'm going to do is paste into it something which is C#8. This is a new feature called tuple switching. So you're able to take a tuple and switch upon that. So it means that we can do based upon what comes into it, we can output something else. So you can, with tuple switching, you can generate a rock paper scissors game pretty easily and pretty succinctly. So I've changed the project type to .NET Core 3, and hopefully some of this red writing will disappear. You don't actually need to do this anymore, but you will have to do that. I used to have to do that. What should happen now is the red writing should go away. So now we're working in .NET Core 3. This application will compile to .NET Core 3. I will need to make, I think I need to make just one modification to the JSON thing to say that we're actually trying to deploy a custom runtime, and it's .NET Core 3.0. So now I've got this rock, paper, scissors function, which is using this tuple switch, which is a C#8 function. This would not be able to run in 2.1. And then in my function handler, I'm basically going to call this rock, paper, scissors method. So I'm just going to take an input string, and I'm going to just split it by a comma. Like it's just going to come in as a string. So I'm going to say either rock, comma, paper, or scissors, paper, scissors, comma, paper. I'm going to split it to an object, and I'm going to pass that object into this rock, paper, scissors function. It's going to take that array of those objects as a tuple, and it's going to then do a switch based upon those two inputs. And what I've done is that's the game logic for rock, paper, scissors. So this is basically a language feature in C#. I would only be able to use it if I'm able to use a runtime in C#, which we do not support in Lambda. But we do support this custom runtime. I was able to say that it's a .NET 3 application. So now what it's going to do when I upload it, it's going to do a little bit more work in that it's going to go and download that runtime, so the .NET framework for .NET 3, and it's going to compile that alongside the Lambda function. So our Lambda is going to be increased in size. There is a maximum size a Lambda function can be, but we're not going to reach that here. And now I can invoke rock, paper, and invoke that, and it returns. And what that means, or what that's proved, is that somehow Lambda is executing the .NET 3 application on a system which doesn't natively support it. And we're doing that using custom runtimes. And what it means is that if for whatever reason you would need this, if you need a specific version build of Mono, or a specific version build of .NET, or a preview release that you need to support or use in Lambda, there is a technical way that you could do that. So I just thought that was a cool thing to show. Last, I wanted to show you some of the services in AWS. There's loads of services that we have. Machine learning services, artificial intelligence services, database services, we've got blockchain services, we've got loads of different things that you could integrate into your application. Recognition is a very simple to use AI service. And Recognition does lots of things, but one of the things it can do is look at an image and label it. So I can look at that image of Lisa Hall and say, and give you a list of things about that image. It's using computer vision to do that. If it was a picture of people, I would be able to look and identify faces, I'd be able to identify emotions, I'd be able to see where their facial landmarks are. If there were celebrities in those photos, it would be able to recognize the celebrities in those things. And so there's a number of different functions of recognition. One of them is the label functions, and I'm going to be able to upload an image and then label that using this recognition service. So the way I'm going to do this is with S3 and Lambda. S3 we've discussed earlier today is our storage system, simple storage service, S3, Elastic Compute, EC2, Elastic Compute, Container Compute, Cloud, Elastic Compute, forget it. So whenever you see a number, it says is doing like K8 or Kubernetes. It's the same sort of concept. I hate it though. I didn't even realize that's what it was for. But SSS and Lambda. So we're going to basically upload an image to S3, and then when that happens, that's going to create a trigger, which is then going to go and call a Lambda function. And then that Lambda function is going to look at what's uploaded to S3. It's going to recognize what's in that image. It's going to generate a list of labels, and then it's going to save those labels back onto the metadata of the object in S3. And you can imagine if you were doing this, and we have customer examples of this where they upload videos, and they use an ML service to transcribe the video, and then they would generate like basically the subtitles for that video. This could also be used for content moderation. If you're building a website and you're accepting information from users, one of the functionalities of recognition is to detect nudity or things like that in images. So you don't have to look at all of the images, but you can guarantee that they're not going to be showing nudity, or you could sort of use this sort of same system to sort of take any content and use AI effectively to delete those sorts of images which have been added by people, so that you don't accidentally show them on a website of drawings that people have submitted for a competition. Someone has a little bit of fun and uploads something which is a little bit racy. We could detect that with this system and delete it from the system, so we never show our customers it. So S3 uploads, an event happens, and we capture that event, it triggers a Lambda function. Lambda then does some work, and then it pastes the labels back into S3. So in S3 we'll have the object, and in its metadata of that object will be these new labels which describe the image.
Do you think they're using S3 and Lambda for the average speed check cameras?
Well, they're using something like that, yeah. It's used by, these sorts of things are used by many different kinds of businesses, and we at Amazon use it for content moderation, for sure.
Can you do text recognition?
Yeah, we have an OCR system. We have one which can do OCR in images and OCR against documents. We have an OCR++ called Textract, which can extract data from images and it can also it can recognise tables, it can recognise Boolean values for ticks. It can also
Sorry, I thought you meant like physical tables.
yeah, it can recognise tables and forms.
Things like here, and then you.
So what I'm doing here is I created a function, a Lambda function. I used one of the blueprints. It's called the detect labels blueprint. It's already done all the code for me. Here's a sample that we have, and I'm basically going to upload that upload that function to AWS. So now that the function's uploaded to AWS, this is roughly what the function does. It has a function handler, and the event that comes in is an S3 event. That's important because depending on the trigger, you might get a different payload. If it's evented by API gateway, which is the URL, this would be an API gateway input. We can have an S3 input, which would be a file. The reason why this is useful is because then we can see what the actual image was that was uploaded. We can find out information about that image. I do the S3 input, it might be one image, it could be a number of images which were uploaded in batch. So I just loop through all of the images in the Lambda function. I check if the image is of a supported type, and then I console write line that we found an object. If it's not of the right type, I sort of exit the Lambda, else I continue. Then I actually call the recognition service. So we have an SDK for all of the AWS services, and this is me using the recognition SDK, the client for it. Every 165 services can be accessed through the .NET SDK. So here's me calling the recognition service using the .NET S software development kit. So I say detect responses, await this recognition client. I'm using a feature in recognition called detect labels asynchronously. I say, I give it a confidence of how confident do I want to be to return objects. And then I pass in an image. I actually pass in an S3 object, and I give it the bucket name and the record name. And that's come in on that S3 object which got passed to my Lambda function. Then once I've got a response, I effectively create a new list of tags. I'm just arbitrarily capping it at 10. I loop through all of the detected labels, which would be detected for that image, and I create a list of tags. So I should end up with a tag list with 10 items in it, and all of those should be the label and also the level of confidence it has for that particular label. Then what I do is I use another client called the S3 client. So I'm now interacting with another AWS service, the S3 service. And what I'm doing now is I'm going to put a tag on the object. You can add metadata to videos and images. So I'm going to add some metadata to each of the images, that image, and basically add the tags to the image. And I think at the time when I wrote this, which is quite a while ago now, there was a limit of having 10 tags per image. I don't think that's the same anymore. That's why I arbitrarily limited it to 10. So I add a number of tags to that thing. So
does that overwrite any existing tags, or would it?
That would, wouldn't it? Because we've got new tagging, tag set, new tagging, tags. Yes, I think it would.
Okay, well you could do it so it adds.
Yeah, of course, yeah. You can, as I say, like I'm doing the most basic thing here and the most lazy thing here, which is generally my way. So there's a few things though now we've got which are problematic, right? S3 and Lambda need to talk to each other. They don't have any right to talk to each other. There's no security context that they have to do that. So we have to give Lambda that permission. So this is IAM, this is security roles. I can go to that Lambda function and I can say, I'm going to attach a policy to that Lambda function. And that Lambda function is going to allow me to call recognition. So if I don't allow this, when I make those recognition calls, I don't provide it with an API key or anything, it will just fail until I give it the policy to be allowed to talk to recognition. So here, I've given it unadvisedly recognition full access. We have lots of different kinds of policies that you could apply. I just give full access because I'm lazy and that's not best practice. But that particular role now, that Lambda function has now got a role which is capable of talking to recognition. You could apply that role to all of your Lambda functions, and you can reduce or remove the recognition access across everything which uses that role. And that's how security works in AWS. It was one of the biggest challenges for me moving from Azure, which is usually based upon API keys. So you'd be given an API key for the Oxford APIs or the Cognitive Services APIs, and you would use that to then call into the service from your SDK. With this, you call the SDK, and it's like weird that there's no authentication, because the authentication happens somewhere else. Add bucket to Lambda. So I'm going to just add an S3 bucket. I'm going to create a brand new bucket. I'm going to do all in Visual Studio, but I could do this using the CDK, the SDK, or the console. I say a bucket for the Beebs. I've got too many S3 buckets. And I say an event source for that bucket. Oh, sorry, that's the function. And I say that function has got an event source of that bucket. So basically, I've just tied those two things together. So the S3 now, anything uploaded will execute that S3 upload function that I uploaded earlier. So the way to test this is if we go into a bucket for the Beebs, and I can actually physically upload objects to S3 from within Visual Studio. We see there's no tags on the image. I upload the demo image, and then when we go to properties, what we will find is for that particular visual thing of Leeds City Hall, we have building, architecture, place, mansion, clock tower, house, tower, city, housing, and we have a value which determines how likely that thing is to be a building or architecture.
80% a palace.
Yeah, it's 80% of that. It's 97% sure it is a mansion. You recognise a clock tower, that it's in a city and housing. What you can think of doing, if you can upload all of your image catalogue to this S3 bucket, you effectively now have metadata against all of this. And this is exactly how your iPhone works, if you've, if to some extent. Or if you go into your application, into your iPhone, into Photos, and you just do a search on Photos, you can search for things that you've never tagged your images with. It's quite fun actually. You type food into your iPhone in the Photos app, and it will just find all the pictures of food.
Other phones also.
Other phones, yeah. Well, yeah. But they're all using this concept. They're all basically doing this either on device or in cloud. They're analysing every photograph. They're labelling every photograph. And so if you have a huge volume of videos, because this works on videos too, and it does it by frame of the video, or of images, you can basically catalogue them and decide what's in them and do all sorts of interesting things with them. And you can use Lambda to do all of this in parallel. And what's cool is if you can imagine, in that instance, if I uploaded 20,000 images to S3, what would happen? 20,000 invocations of Lambda all working in parallel. That's one of the amazing things about it. I wouldn't be bottlenecked by a single machine. It would just create that all in parallel. And that's one of the powerful things about serverless computing, this concept of complete parallel workloads and scalability, which would previously be very, very difficult to do.
Is the videos or by frame? Do you get tags per frame?
We do really interesting things in video. So we can monitor objects over time in video. So we can, like, if one of the examples we'll show is, or we often show is, like football players as they move around a pitch. We can not only tag the person, but we can say if it's the same person as they're moving around the pitch, the direction that they're moving in, that sort of thing. We have really interesting. The image one's really good for facial. We can even detect faces with occlusion and like things over the face and stuff like that. So it's quite an interesting sort of service. The point more being that any of those machine learning services can be accessed from .NET in either serverless, in container-based applications, in standard ASP.NET MVC applications, in console applications, in WPF applications. They're all supported, and we allow .NET developers to do whatever they want from wherever they want in whatever tool that they want. That's the idea anyway. Most of the stuff that we do with AWS and .NET is open source, and you can look at our GitHub repository to see the stuff that we're working on, or to contribute, or to ask for things. One of the best places, if you've got an issue with anything like SDKs or CDKs, going here and logging that on our GitHub repository will be probably one of the easiest ways if you don't have an account manager at AWS to kind of deal with that, or ask for a new feature or find out what the progress of the feature is. I just also want to mention we have these things Cool. Gentleman at the back over there with his hand up, who knows all about these. These are some AWS .NET developer dojos we're running in Manchester. They are a bit of an experiment, I guess, in terms of what we're doing, but the whole idea is it's a full day of learning about .NET development for AWS. We're hosting it in Manchester on March the 5th and March the 4th at the Co-op. I'm assuming that's like the offices of the Co-op.
It's called the Federation. It's their sort of tech.
Good. So it's not a shop. Right. He's going to be at the back of the Co-op next to the bread aisle. Yeah. So he's doing in Manchester, and like it would be cool to see some of the people in this room maybe come along to those days of training. Anyone can sign up for them and come along.
It's free.
Is it free?
It's free.
It's free. The cool thing is if these things are a success in Manchester and if you do .NET developers in Manchester, do let them know these things are going on in March, because we'll be able to start doing them all over the country. The more success these things get, the more likelihood that we'll be able to do things like this and activities like this to support the .NET ecosystem. My name's Martin Beeby. I'm at the Beebs on Twitter. I'd really love it if you've seen this. If you want to evaluate this talk, you can scan this code and you give me a rating for my talk. And some feedback or comments that you might want to add. You can add your email address to it, but it's not GDPR compliant, so don't if you have a problem with that. In return, when you do this and you sign up and you click 3 things and press submit, you'll get a $50 credit for AWS. So it's worth doing.
Does that invoke a Lambda?
Sorry?
Does that invoke a Lambda?
It's actually hosted on a thing called Amplify Console. But it does use lambdas in some aspects of it, I'm sure. It's not actually built in .NET though. So it's built by a friend of mine in Python, I think. Or Node, actually. I know a guy on our team which built this as a way of distributing credits and also getting feedback from our talks. Thank you very much indeed. I've been Martin Beeby. Good night.
Thanks all for coming. If you haven't picked up one of the cool .NET Leeds Sharp t-shirts, there's still loads left, so as a thank you, we'll give you a t-shirt, and drinks are on us at the brewery tap now if you fancy a bit of chit-chat.